here we go. It's Thursday, and we're ready to get going with transition environments. Okay. Actually, before we get started, there's a bunch of, and I probably don't have it in scroll back now, but there's a bunch of Clippy errors I would like to clean up before we dive into environments. And I think most of it is this issue with the rights being should be rightlands. So let me clean those up first. That shouldn't take too long. If I look for right bang and change them all to rightland and remove the \n from each one of these, that should get rid of a lot of the Clippy warnings. That one we want an extra \n. Rightland. I'm not sure if it's all that significant to do this, but I mean, it's the same number of characters, right? We're not making the code smaller or shorter or whatever. But I don't like Clippy warnings. This is all over the place, isn't it? Almost done. Hello, Shiloh. How are you? A little bit more cleanup here. And then there were a few other issues with, I forget what they were, using vec instead of a slice. And we can certainly clean that up too. That's easy enough to do. Oh, and the other issue I wanted to clean up was we should have added the statement that we created yesterday to git ignore. Git remove. Yeah. Okay. Git status. Okay. So we deleted that. We added that. We modified that. Git cargo Clippy there should be fewer warnings now. So this locks AST generated 5, but the build script generated 23. So hopefully some of those are gone. Oh, right, and then using the slice directly. Let's do that. Shiloh says, I've started reading the book too. Good, I hope you enjoy it. I've definitely been enjoying this a lot. But it might be easier just to do it in Java directly rather than trying to. And I wonder if we can change all these. Instead of saying string, we can just say stir here. Right? And get rid of all of these two strings. That one we need, but here, maybe base name, we can say stir. Let's see if that. Oh, it doesn't like something. Oh, that should be. How did I delete that guy? Okay, so that worked. And what were the other Clippy warnings? We fixed these two. Yeah, they're all the rightland things. Anything else? Rightland. All right, so let's rerun Clippy. And, oh, we still have 5 warnings. Oh, we don't need to ampersand those guys anymore. And this can be a stir. Okay. And then this can just be this. And this can be this. And this can be stir. And then was something about split. What was it saying about split? Oh, args is split. On line 54. Can be a character. Okay. I don't know why it doesn't mind about this being a string. Okay, so that all builds, and then we have these 5 warnings. Oh, we're wrapping this in an OK. We don't need the OK there. So interpreter 32. Yeah, we can just return that directly. Remove the return on line 103. Oh, because the match is doing a return. Okay. And that means this can go away as well. Check. Nope. Oh, no question mark then. Yep. Okay. And then finally, parser. The vector tokens changes into an array of tokens, and 160 can just be self-primary. Okay. So this becomes this. Oh, is that going to be an issue here? Maybe this needs to be this as well. And then 160 is just this. Yeah, okay. So cargo, Clippy. Did we catch everything? All right, we did. Nice. Okay, so let's commit these changes. Okay. Clippy cleanup. Okay, and yeah, so I removed the statement because we generated it. Right? If I say rm source expr and source statement and cargo build, generate script. Ooh. Oh, that's good to know. That doesn't work. Did my build script not run? Wait, no, we've been using this all this time. This calls generate AST. And I guess this can just be this now, right? Yeah, so now they got built. But so cargo build should have built them. Maybe it doesn't build them. Oh, maybe I have to do a cargo clean. Let's see. RM source statement and source expr. Cargo clean. And then a cargo build. Maybe it didn't detect any changes in my build script, so it didn't try to build them. Yeah, okay, that was it. All right, good. And how do you do amends? Git amend last commit. Just tell me the command to do it. Git commit amend no edit. Okay. Git add build. Git commit amend no edit. There. Okay. Yeah, so Clippy cleanup, we removed statement from our thing, we cleaned that up, and then we cleaned all these things up. Very good. Oh, and yeah, and then we deleted the statement because that's not supposed to be part of our repo. That's supposed to be generated code. Okay, so now I think we're ready to dive into environments. Supercuber was telling me a few days ago that this is where things all go pear-shaped. So let's see what happens. The bindings that associate variables to values need to be stored somewhere. Ever since Lisp folks invented parentheses, okay, this data structure has been called an environment. I like to imagine the environment literally as a sylvan wonderland where variables and values frolic. Okay, you be you. Right. So you can think of it like a map where keys are variable names and the values are the variable's values. Sure. So it's a hash map, I guess. In fact, that's how we'll implement it in Java. We could stuff that map and the code to manage it right into the interpreter, but since it forms a nicely delineated concept, we'll pull it out into its own class. Java calls them maps or hash maps. Other languages call them hash tables, dictionaries, hashes, tables, associative arrays. Way back when, they were known as scatter tables. Cool. All right, start a new file and add this. So we're going to just have an environment struct, I guess, in Rust. We'll do it as environment. We'll have to use standard collections hash map. And then we're going to just use pub struct environment. And we will have, this is just called values. There's a hash map from string to object, which means we'll need to pull in the object. And then we need to link it in to our main. So let's just throw it here, mod environment. Mod object is here. Yeah, I'm still thinking about whether or not to continue with AST printer because it's now out of date, right? If I look at AST printer, it doesn't have, we've been growing this and we also have the statement printer. Should we continue with that or no? And I'm guessing no. But maybe it might help us debug later. Maybe I'll take one stream to clean that up. All right, so does that build? Does it check? It does. We have 2 warnings, and probably that's because environment's not used. Yeah, struct is never constructed. Okay, there's a Java map in there to store the bindings. It uses bare strings for the keys, not tokens. A token represents a unit of code at a specific place in the source text, but when it comes to looking at variables, all identifier tokens with the same name should refer to the same variable, ignoring scope for now. Using the raw string ensures all of those tokens refer to the same map key. Right, because you can have 2 different tokens with the same string representation, and you want them both to refer to the same variable. That makes sense. Okay, there are 2 operations we need to support. First, a variable definition binds a new name to a value. So we're going to create a define. Yep, okay. So we're going to say pub impl, no, not pub impl environment, pub. I guess we should create a new first. Because why not? And now we'll create the define and it returns a void. So pub fun. Define, and it takes a name, which is a string, and an object, which is a value, and does not return anything. Okay, and then we just say self value. Oh, we need a mut self. Self values. What's it in Rust? I think it's insert, right? Name value. Go check. Everybody's happy. Okay. Not exactly brain surgery, but we've made one interesting semantic choice. When we add a key to the map, we don't check to see if it's already present. That means that this program works. Var a equals before, print a. Var a equals after, print a. All right, so shadowing, right? A variable statement doesn't just define a new variable. It can also be used to redefine an existing variable. We could choose to make this an error instead. So yeah, immutable variables. The user may not intend to redefine an existing variable. If they did mean to, they probably would have used assignment, not var. Making redefinition an error would help them find that bug. Oh, okay. So saying make this illegal. My rule about variables and scoping is when in doubt, do what Scheme does. Okay, I've never used Scheme, so I will just merrily go along with that. The Scheme folks have probably spent more time thinking about variable scope than we ever will. One of the main goals of Scheme was to introduce lexical scoping to the world, so it's hard to go wrong if you follow in their footsteps. Scheme allows redefining variables at the top level. Okay. However, doing so interacts poorly with the REPL. In the middle of a REPL session, it's nice to not have to mentally track which variables you've already defined. We could allow redefinition in the REPL, but not in scripts. but then users would have to learn two sets of rules, and code copied and pasted from one form to the other might not work. So to keep two modes consistent, we'll allow it, at least for global variables. Once a variable exists, we need a way to look it up. All right, so we're not going to do this. I guess we could write a simple test. But, I mean, is there any point? All we're doing is calling this, but we could at least see that it works. Fun can define a variable. Right, and then just say define. One, and we'll, I don't know, I guess we'll just say object bool true, and that should work. It doesn't return anything, but we can assert that e.values contains key. Oh, not it contains key, contains 1. And I think capitalization counts. So let's see. Test. Oops. I use Superstar. E-N-V-I-R-O-N-M. Oh, M-E-N-T. Oh, toString, right. Okay. What is it then, if it's not contains? Rust hash map contains. It is contains key. I thought that was for hash key, hash sets. Okay, one more try. Expected reference found string. Here we go. Okay. Here we go. Can define a variable. All right. And then we want to be able to say fun can redefine a variable. Mod E. Environment new. So now we'll just copy this. And we'll change it to a, I guess we can change it to a num. 12? We didn't actually assert that the value was bool true. I guess we can do that. Assert eq bang e values get 1 to string unwrap is equal to object num 12.0. And we should call this 2 just because. And then we should be able to just copy that line and paste that and change this to 2 and change that to, oh, nope, that was a mistake. Bool true. Okay, so let's see if that test works. No. No implementation for object. Oh, we have to ampersand it. Okay. There we go. Okay. So we can redefine a variable. Very good. Okay. I'm happy. So now we're going to write what? What are we doing? Get. Sorry, right. Once a variable exists, we need a way to look it up. Okay, so let's write a test. Fn can get a predefined variable. Predefined is not the right word there. Let's just say can look up a variable. And we'll just do this. Let's call it 3. Let's make it a string of foo to string. Right? And then we want to be able to say assert eq, bang, e.values dot, oh, e.get 3 to string is equal to object stir foo to string. And that's not going to work because we don't have get yet. Oops, I forgot a comma somewhere. Yeah, no method get. Okay, so let's write method get. And method get looks like this. So it's going to return an object, pub fun get, mut, not mut. We don't need a mut if we're just doing a lookup, right? Name, token. Should be a reference, passed by reference, I guess. And then object. Oh, no, it needs to throw a runtime error if we have an issue, right? So it's going to be a result of object or locks error. And then, oh, that's right. Then we need to import that. So now we're going to say if values contains key, return it. So we can say in Rust, we can say if let some object, right, equals self values get name. Oh, name dot lexeme here, but we changed it. We called it something else. What did we call it? Object. Oh no, it's token. As string. Okay. Oh no, I have lexeme to string. Yeah, I can just say as string, right? Like that. I should probably write a from for it, right? If I'm going to call it as string, but okay. If that works, then we're going to return OK object. Else, it's going to be an error, which is locks error, which is a runtime error. And we're going to give it name as our token. Let's take a look at the error API because I haven't looked at that in a while. Runtime. Yeah, token. Oh, reference to a token, and then a reference to a string, which is just undefined variable. Oh, we have to format it. Undefined variable tick dot comma name as, oh, that's got to be call string. Okay, so, and we should actually write a test for that to make sure that it doesn't try to return something we don't have token in scope. Oh. Oh. Do we need to clone this out? Okay. And if we run this as a test now, it doesn't like it. Oh, because it's a result. It's a result. Okay. Yeah. Let result equals e get 3 to string. And then we're going to say dot OK. I guess we could just put that here. Nope. Expected token. Oh, expected token. Now we're using a token to look it up. Right, so we need to create a new token. So let's do that. Let 3 talk is equal to token new. And this is going to be a token type identifier. I've forgotten it. Okay, look it up. And there's the new. Okay, so it's token type, then lexeme, which is what we actually care about, which is the 3 to string. The literal is none, and the line we don't care about. So now what we're going to do is say get 3 talk. Nope. Oh, we have to pull in token type. Wow. Oh, actually, we don't need it there, right? We just need it here for now. Let's see. Yeah, we'll keep the scope to a minimum. Expected enum option found object. Unwrap? Maybe I can just do unwrap directly. Nope. Expected enum object found object. Oh, okay. Yeah, there we go. Okay. And now we want to test returns error when variable undefined. And then we can just say assert bang e dot get. Oh, right now it's not defined. So if we say e dot get 3 talk is error. And I'm not going to parse the error message and all that kind of jazz. Oh, that's right. It doesn't have to be mutable if we're not actually muting it. So apply that, run that, and we're all good. 22 passed, 0 failed. Good. Okay, so we got this far. This is a little more semantically interesting. If the variable is found, it simply returns the value bound to it. But what if it's not? Again, we have a choice. Make it a syntax error, make it a runtime error, allow it and return some default value like nil. Locks is pretty lax, but the last option is a little too permissive to me. Making it a syntax error or compile time error seems like a smart choice. Using an undefined variable is a bug, and the sooner you detect the mistake, the better. The problem is that using a variable isn't the same as referring to it. You can refer to a variable in a chunk of code without immediately evaluating it if that chunk of code is wrapped inside a function. If we make it a static error to mention a variable before it's been declared, it becomes much harder to define recursive functions. Okay. We could accommodate single recursion, a function that calls itself, by declaring a function's own name before we examine its body. But that doesn't help with mutually recursive procedures that call each other. Consider this. So if odd, if n is 0, return false, return is even and -1. Okay, this is interesting. Granted, this is probably not the most efficient way to tell if a number is even or odd, not to mention the bad things that happen if you pass a non-integer or negative number to them. Bear with me. Yeah, it's just an example. I get it. But is even doesn't even exist, right, until here. And the way C handles this is you have to pre-declare is even up above is odd, or up above this, at least. The is even function isn't defined by the time we are looking at the body of is odd where it's called. If we swap the order of the two functions, then is odd isn't defined when we're looking at is even's body. Since making a static error makes recursive declarations too difficult, we'll defer the error to runtime. It's okay to refer to a variable before it's defined, as long as you don't evaluate the reference. That lets a program for even and odd numbers work, but you get a runtime error in this. You can't print A before you var A equals too late. As with type errors in the expression evaluation code, we report a runtime error by throwing an exception. The exception contains the variable's token, so we can tell the user where in their code they messed up. Some statically typed languages like Java and C# solve this by specifying that the top level of a program isn't a sequence of imperative statements. Instead, a program is a set of declarations which all come into being simultaneously. The implementation declares all of the names before looking at the bodies of any of the functions. Older languages like C and Pascal don't work like this. Instead, they force you to add explicit full-word declarations, right? To declare a name before it's fully defined. So just as an example, in this even-odd thing, if this were a C function here, it would be int is odd, int n, which would say if n equals 0, return false, and then call return is even n minus 1. But for this to compile, you'd have to put up at the front int is even, int n, semicolon, and then write int is even down here, and with the body of is even. So that way the compiler will see, oh, is even is declared up here, so I know what type it is. And then when it's here, it has to match exactly this, and if it doesn't, then the compiler will say, oh, you previously defined it this way, but now you're defining it this other way. Right? If I put a float here, the compiler would die because it doesn't match that signature. But that's C. Rust doesn't do that. Okay. That was a concession to the limited computing power at the time. They wanted to be able to compile the source file in one single pass through the text, so those compilers couldn't gather up all the declarations first before processing function bodies. I mean, that's reasonable. You make do with what you have, right? So here we go, interpreting global variables. That's right. We've added this var statement, and I commented it out, or I stubbed it out here. Here's a visit var statement, and all I have is an OK. But looks like here, the interpreter class gets an instance of the new environment class. So it's going to have an environment in here, which is going to be interesting. Environment, and oops. That's going to give me trouble all throughout the rest of this, isn't it? environment. There we go. And then when we create a new one, we need to actually, I guess we need a new now. We don't have a new yet. Pub fun new. Interpreter, environment. New. Oh, and then in our main, we're going to have to do interpreter new. Yeah, that's easy. Okay, does this check? It does not. Of course not. Oh, because we don't have environment here. Okay, so that checks. We store it as a field directly in the interpreter so that the variable will stay in memory as long as the interpreter is still running. We have two new syntax trees, so that's two new visit methods. The first is for declaration statements, right? So visit var statement, which is right here. Oh, okay. So I was going to start trying to write tests for these, right? But this is going to be a little difficult because we actually have to create var statements. Object value is null. If statement initializer is not null, then value is evaluate the statement initializer, and then environment define statement name lexeme value. We could do this, right? Because all we're doing is calling evaluate on the initializer, and we can make the initializer very simple, right? We can just say, a number. And then when that gets evaluated, just value becomes that number. So how do we implement this in Rust? Well, let's write a little test. Let's see if we can actually do this. Test var statement. So we have to actually create a var statement. Let var statement is equal to var statement. And it just has a value. No, it has an initializer and a name. Oh, and a token. Okay, so name is going to be a token, new. Token type identifier. The lexeme is just going to be our variable name. The literal is going to be none, and the line number we don't care about. So that's that, and then we have the initializer. which is going to be, that's evaluate, fun evaluate, which takes an expression. So we can create a literal expression, right? We already have that. Make literal. So make literal object num 23. Okay. And now we should be able to call, oh, we have to create the terp. Oh, all of these interpreters have to change now. Okay. Oh, might as well do that now. Interpreter. So change it to interpreter : new. Okay. So let's grab that line, put it here. And now we can say terp.visit var statement of var statement. And then we should be able to say terp environment get. It's kind of cheating, right? But oh, let's create this as a token type out here. So that we can use it in more than one place. Name.dup get name, and it should be equal to object num 23.0, which means we want to do an assert bang unwrap, right? And if we run this test, it should fail. Wow, it failed in multiple ways here. Oh, assert EQ. Okay. Expected option. Oh, right. This is a sum. Oops. I guess we should also test the nil case as well. And then what didn't it like here? Cannot apply unary operator bang. Oh, that was because I messed up the assert, right? Pub enum object must implement not. Okay, we don't have to do all that because I've messed up the macro. Run tests. Expected this found box. Oh, make literal has a box. Can we dereference it like this? Or will that, oh my God. Or will that give us a can't copy error? No? Okay, so we got a failure. Is it a failure because it's undefined? Yeah. Which is good because we were supposed to try to visit the var statement and then try to get the value. The var statement doesn't do anything yet. So that's good. So it failed for the right reason. But there was something else here. Oh, right. This needs to be okay. So assert bang is okay. Okay, let's run that. Did I clean up that first problem? It did. Good. Okay, so we still have the failure. Let's write the code and see if we can get this to work. So we need to do, say, so the way we're going to do this is we're going to say let value is equal to if let some initializer is equal to statement without the underscore statement initializer. Then we're going to return self-evaluate initializer question mark, else we're going to return object nil. Right, and that way if it's not there, we're going to pass the null value into here, which is what we have as object nil, and then we need to do environment self environment define. Oh, we already have a problem because these are not mutable. All right, interior mutability to the rescue. Ref cell. Boom, done. Almost done. Fun new. Ref cell new. Bam. Use standard cell. Ref cell. Bam. Okay. Self environment borrow mut dot define. And then we need the token, which is, oh no, we need the string. Statement name as string and our value. And then we're just going to return an okay of whatever that returns. Oh no, it returns a void. So we can do this, semicolon, and then okay. Will this even? It doesn't even. Oops. If I do it like this and it's saying use string, expected struct string found string. Oh, should our define method take an ampersand string then? Probably. Oh, and then this won't work to string. And this needs to be an ampersand. Oh, okay. And let's run our test. And everything blows up. Oh, yeah. So all of our environment tests died because we changed the function signature. Should have seen that coming. So let's look for all the places where we call define and just change it to an ampersand here. Okay. Test. Still doesn't work. Method not found in ref. Oh, we don't have 411. Oh, that's wrong file. 411. We can't just call get, we have to say borrow get. Nope, you got to spell it correctly as well. DS Legends, thank you for the follow. Ooh, look at that. 23 tests passed. Nice. Okay, so this test worked. Our test of a var statement. Now we should also be able to test we should get back a nil if the object is not defined. So let's copy this test. Defined, undefined. And instead of doing this, we should be able to pass in none for the initializer. And then this should be okay, and this should be equal to nil. Right? 24 tests pass. Perfect. Okay. So if the variable had an initializer, we evaluate it. If not, we have another choice to make. We could have made this asyntax error in the parser by requiring an initializer. Most languages don't though, so it feels a little harsh to do in locks. We could make it a runtime error. We'd let you define an uninitialized variable, but if you access it before assigning it, a runtime error would occur. It's not a bad idea, but most dynamically typed languages don't do that. Instead, we'll keep it simple and say that locks sets a variable to nil if it isn't explicitly initialized. So var a print a. Thus, if there isn't an initializer, we set the value to null. Right? So actually, should this work at this point? If I say print a, it prints nil. Okay, so that part of it works. We're not calling get anywhere. Oh, right, because we haven't written this part yet. Okay. Thus, if there isn't an initializer, we set the value to null, which is the Java representation of locks' nil value. Oh, Bruno Farias Dev, thank you. Thank you for the follow. Okay. Then we tell the environment to bind the variable to that value. Right, so we do insert into the environment a nil. Okay, so next we evaluate a variable expression. So visit, we already stubbed it out. Here it is. To always, oh yeah, it's always returning nil. So that didn't really test anything. Printing that out. All right, so next we evaluate a variable expression. Can it get, does it return an object of that type? Huh. I'm pausing because, no, we don't have environment in Git files yet. We're about to though, because I can tell we're about to check this in. Yeah, this returns an object or a LOX error if it doesn't exist. This simply forwards the environment which does the heavy lifting to make sure the variable is defined. Right, so we have to handle that here, which means we just, oh, yeah, so we can just say self environment borrow get, and then this becomes this, and this becomes exper name. We're just passing in a reference to the token, and this will handle the LOX error versus object thing for us. So it's a very simple piece of code. So we should be able to, before I write this, let's make this return a nil, just like we had before. And we should be able to write a test now, which calls that after we define a variable. So let's use this code to define our variable to be the number 23. And then instead of going environment borrow get, we're going to just call get directly on the terp and give it a, not a name, but a variable expression. So we visit the var statement, this inserts it into our environment, and now we have to create let variable var expression is equal to var exper, and this just contains a name, right, which is a token. I think that's all it contains, right? Let's take a look. No, that didn't work. Source exper. Oh, because it's called variable exper. That's why. Yeah, and just contains a name token. So we throw that in there, and we assert equals that var exper unwrap is 123, and then everybody's happy. So let's run that test, and that should fail. Well, let's get it to compile first. Oh, I got to rename it. So variable expression. And I spelled this wrong. V-A-R-I-A-B-L-E. And what else is wrong? Method get not found for that? Really? Oh, it's visit variable exper. Right. Okay. Let's run that test. Something's still wrong. Oh, yeah, this is fine because we're about to fix it. And this failed, which is correct. It returned a nil, and we were expecting 123 as a number. So let's go to this. Oh, that's... I was hoping to get here. There we go. So now we put this piece of code in there. That checks. We run the tests. 25 tests pass. Okay, so that works. What's the other thing? Oh, it could be a runtime error if we tried to get a variable that doesn't exist yet. So that should also work. So variable undefined variable exper. So we do the same thing here, except instead of inserting something, we just assert that. All right, there's our variable expression. And now we want to visit it, and we want to return that is an error. Oh. Oh, all right. This is what I want to do. what did I do? Oh, var expr. One more try. There we go, 26 test pass. Okay, so this is all working. This is great. So we just finished section 8.3. I want to get status, git add source, git show diff stage. Okay, so what we did was we created this new environment file, which contains our new a get and a new a define and a get. We got some tests for that, and then our interpreter, we actually implemented the functions that we stubbed out yesterday. Well, we added the environment to it as a ref cell because we needed that interior mutability, and then we implemented the logic for visit var statement, which we had stubbed out yesterday, and the logic for visit variable expr, which is a single line. We wrote a new here, and then we added tests to the interpreter for all the stuff we just did. And then what's this? Main. Oh, right, main. We needed to add the environment so it gets linked in. Okay, good. Git commit -m section 8.3 environments. Okay. So now we're up to assignment. It's possible to create a language that has variables but does not let you reassign or mutate them. Haskell is one example. SML supports only mutable references and arrays. Variables cannot be reassigned. Rust steers you away from mutation by requiring a mute modifier to enable assignment. Mutating a variable is a side effect, and as the name suggests, some language folks think side effects are dirty or inelegant. Okay. Code should be pure math that produces values, crystalline, unchanging ones, like an active divine creation, not some grubby automaton that beats blobs of data into shape one imperative grunt at a time. I find it delightful that the same group of people who pride themselves on dispassionate logic are also the ones who can't resist emotionally loaded terms for their work. Pure, side effect, lazy, persistent, first class, higher order. All right. LOX is not so austere. LOX is an imperative language, and mutation comes with the territory. Adding support for assignment doesn't require much work. Global variables already support redefinition, so most of the machinery is there now. Mainly, we're missing an explicit assignment notation. Okay, so let's add assignment syntax. 8.4.1. That little equal sign syntax is more complex than it might seem. Like most C-derived languages, assignment is an expression and not a statement. As in C, it is the lowest precedence expression form. That means the rule slots between expression and equality, the next lowest precedence expression. In some other languages, like Pascal, Python, and Go, assignment is a statement, right? So this says an assignment is either an identifier followed by an equal sign, this line here, or an equality, and thus any other expression. Later, assignment will get more complex when we add property setters on objects like instance.field equals value. The easy part is adding the new syntax tree node. And then we have the generated code, but we're generating our own code, so there's no reason to go look there. Let's modify this in our AST binary. We're going to add sign. And it's going to take a token name and a box expr value. Nice. Okay. It has a token for the variable being assigned to and an expression for the new value. After you run the AST generator to get the new expr assign class, swap out the body of the parser's existing expression method to match the updated rule. So we're just going to call assignment from expression. Right, expression is going to call assignment. It used to call equality, but now it's going to call assignment. Okay, so if I run this now, we're going to get a compilation error in interpreter saying we don't have visit assign expr implemented. But before we get there, we're going to the parser. Here we go. So here's expression. So instead of calling equality, we're going to just call assignment. So that's pretty straightforward. But here's where it gets tricky. Uh-oh. A single token look-ahead recursive descent parser, say that 10 times fast, can't see far enough to tell that it's parsing an assignment until after it has gone through the left-hand side and stumbled onto the equal sign. You might wonder why it even needs to. After all, we don't know we're parsing a plus expression until after we've finished parsing the left operand. The difference is that the left-hand side of an assignment isn't an expression that evaluates to value. It's a sort of pseudo-expression that evaluates to a thing you can assign to. Consider these. On the second line, we don't evaluate a, which would return the string before. We figure out what variable a refers to, so we know where to store the right-hand side's expression's value. The classic terms for these two constructs are L value and R value. All of the expressions that we've seen so far that produce values are R values. An L value evaluates to a storage location that you can assign to. In fact, the names come from the assignment expressions. L values appear on the left side of the equal sign in assignment, and R values on the right. We want the syntax tree to reflect an L value that isn't evaluated like a normal expression. That's why the expr assign node has a token for the left-hand side, not an expr. The problem is that the parser doesn't know it's parsing an L value until it hits the equal sign. And in complex L value, that may occur many tokens later. Like this, make list, open print. So there's 1, 2, 3, 4, 5, 6, 7 tokens before we hit the equal sign. So we can't just look one token ahead. Since the receiver of a field assignment can be any expression, and expressions can be as long as you want to make them, it may take an unbounded number of tokens of look ahead to find the equal sign. We have only a single token of look ahead, so what do? We use a little trick, and it looks like this. So we're going to call equality. If it's after the equality, if we see an equal sign, then we get match or goes past the equal sign. So then a previous becomes the equal sign. Value becomes the assignment. So it's recursive. And then if it's a variable expression, then we create the assignment. And if it's not a variable expression, that's an error. If we don't match an equal sign after calling equality, then we must not have an assignment, and we must just have a regular expr. And so we return an expr. So where does a statement come from? I guess. Right, because isn't it a statement? Oh, right. You said before that these are assignments are expressions, not statements. So we don't have to worry about that part of it. That makes sense. This says we report an error if the left-hand side isn't a valid assignment target, but we don't throw it because the parser isn't in a confused state where we need to go into panic mode and synchronize. Oh. So we're not going to abort here. We'll just report the error and then return the expression that we found. Okay, so this is where things diverge. Because right now, error, if we call error, that sets a had error value on the parser. Maybe, because we have, there. That should be assignment. And then we need to write assignment. But now I have to think about how we're going to handle this. Because right now the way, let me just split the fn error. We create this error. Oh, this just generates an error, a parse error, which does do the report. So we can call error and then just return the expression. But we want to be able to save the fact that an error occurred, so we don't try, after parsing it, trying to interpret it. So I think we have to refactor this a little bit. So before we do this, before we do this assignment thing here, I'm going to put that back to equality. We should be clean at this point, right? Oh no, we modified this. Okay. So we're not quite clean yet. Let me stub out Actually, let me revert that because it's just a one-line change, right? Git diff. Yeah, all we did was add this one line. So that we can do again. Git checkout dot. Okay, so let's fix up the parser because I think we need to have a had error. Which is just false. And then in our function error, we're going to take a mut self. I don't think there are too many places where we call this actually. And then so we'll just say self had error is true. There's probably a sloppy way to do it. Oh, right. We should actually fix this because I don't think this is right either. But here's parser error. So we should change this to self. Yeah, and that's actually the only place we're using it right now, but we'll use it elsewhere, I'm sure. Let me go back and take a look at how we generated this code. Because this, I'm bothered by that our line number is 0 here. There should be a way to get the line number. Do I do that now or do that offline? Because we're in the middle of this right now. Okay, so I'll do it offline, or maybe at the end if there's a little bit of time. Okay, so now after the parser runs, we want to say if parser had error, except that's not a pub, is it? Let's do this. Parser success, then do this. Oh, wait. It's the other way around, right? If parser dot success end. There we go. And then what we'll do is write parser success as a public function here. Pub fun success self returns bool, and that's just self, not self dot had error. Okay. And this doesn't like it here. Oh. Let peak equal self peak. I think that fixes it. Nope. There, okay. When in doubt, clone your way out of problems. Okay. So this is just allowing the parser to return errors if errors were encountered during parsing. Git status, git add source, git commit. Oh yeah, I could have used git stash. I'm not that familiar with git stash for the other change that I had, and then unstash it, I guess. Allow the parser to not return. I don't want to say return. Record and report errors back to the runtime, I guess. Not too thrilled with that. Okay, so now I'm gonna stop not being thrilled with it, and we'll go back here. This was the sign, and it was what? I've already forgotten. Here it is. Token name and box expr value. Okay, that's all we did, and then we changed this line here. So expression became assignment. And now we have to write this, and this will allow us to set the error after parsing, and that way we won't try to interpret something that doesn't parse with an invalid assignment target, right? Like if somebody writes 3 equals 4 as opposed to 3 equal 4, we should get back an invalid assignment target. All right, so this is saying put assignment after expression statement. Sure, why not? I don't know why all the way down there, but sure. FN assignment, not self. Oh, it doesn't take any inputs, and it returns the result of expr or locks error. So let expr equals self equality, question mark. Then if, we should have similar code along the way that we can, yeah, self is match. Token type equal. I should split this out because I don't want to have to create an array of 1 everywhere. I do it a lot of places. Well, here's 2, here's 4, but there's a bunch of places where we only have 1. So it'd be nice to have something for that. So okay, so we parse in an expression. If an equal sign is after it, oh, assignment, right? We renamed it assign. Then let equals is equal to self previous dot dup. I'm just going to follow this code here, and then let value equals self assignment question mark. And then this says if expr is an instance of expr.variable. And our code, what do? We say if let sum expr equal. So we're going to shadow this expr here. Expr variable. Expr. I think that's it. And then we just say let name equals expr.name. I don't know why we have to do that. I don't think we have to. I think we could just say okay, or return okay of expr assign expr, and it's going to be the token is going to be expr.name.dup, and then value. Let me see. I have to look it up now. Expr. Where's our assign expr? Yeah, it's a value of a box expr. Okay. And it's this value here, which isn't boxed yet. Box new value. Right? So, I think this is the equivalent of this code here. Right, we're just saying if it's an instance of this variable, well, we can just use Rust destruction to get that, and then otherwise we say self error equals invalid assignment target, but we don't throw the error. We just report it. And then throw away the return code, and then otherwise we're going to just say okay expr. Check. Fail. Oh, because we don't have assign expr. Okay, but let's see if we have any errors over here, and we do. What is the error? Expected struct variable expr found expr. Dang, I thought we could destructure it like that. Oh, duh, expr variable. I got this backwards, wow. That's what I wanted to do, right? I want to say if I can destructure this into a variable expr, then do this, right? Okay. Yes, I know. Oops, I didn't mean to run tests. I meant to do this. Okay, so it didn't like this. Assign expr does not have token. Oh, right, it's name. And then equals, it didn't like. Do I have to ampersand it? Yeah. Okay. That's it. Okay, so that This compiles. So we just have to write visit assign expr. Okay. Most of the code for parsing an assignment expression looks similar to that of other binary other binary operators like plus. Oh, sorry, 434. Says, do you think it's a good idea to take notes on everything when you're learning to code or use resources online for reference? I don't take notes. What I do, so if I'm learning something, I learn by doing. So one of the other things I stream is this Rust roguelike tutorial, and it has a bunch of Rust code in it. So the way I learn this is by taking this and typing it in myself rather than copy pasting. And that's how I learn. And then I have my own code to refer to when I'm doing stuff. So yeah, I don't do notes. My brain doesn't work that way. But everybody's different, right? So you got to do what makes it easiest for you. Find your happy place for learning and stay there. I didn't mean it that way. Okay. Sorry. We parse the left-hand side, which can be any expression of higher precedence. If we find an equal sign, 434 says right on. Yep. If we find an equal sign, we parse the right-hand side and then wrap it all up in an assignment expression tree node. Right. So that's what we're doing here. So we parse the left-hand side here. If we find an equal sign, right, we parse the right-hand side. Oh, not there. Here. That parses the right-hand side. And then if it turns out to be if this is a variable expression, then we wrap it up in an assignment statement. An assignment expression tree node. One slight difference from binary operators is that we don't loop to build up a sequence of the same operator. Since assignment is right associative, we instead recursively call assignment to parse the right-hand side. So that means we could have several assignments. We could say A equals B equals C equals D. It could be an expression. So we parsed A, we found an equal sign, so now we parse assignment again to see if the rest of it is an assignment. And we keep going until we hit the semicolon. Right? So that's what this paragraph means. The trick is that right before we create the assignment expression node, we look at the left-hand side expression and figure out what kind of assignment target it is. We convert the R-value expression node into an L-value representation. And that's what this line is doing. Right? Because we're casting expr into expr variable. We extract the name from it and then pass that in as our assignment target. This conversion works because it turns out that every valid assignment target happens to also be valid syntax as a normal expression. Consider a complex field assignment like this. New point, x plus 2 comma 0 dot y equals 3. The left-hand side of that assignment could also work as a valid expression. So you're saying this could just be a valid expression. Yep, we could just be extracting y and printing it out or whatever, reading it. But if there's an equal after it, then we can convert that into an L value. You can still use this trick even if there are assignment targets that are not valid expressions. Okay, define a cover grammar, a looser grammar that accepts all of the valid expression and assignment target syntaxes. When you hit an equal sign, report an error if the left-hand side isn't within the valid assignment target grammar. Conversely, if you don't hit an equal sign, report an error if the left-hand side isn't a valid expression. Okay, I see where they're going, but that's a little beyond my capabilities right now. Right, so they're showing that this could be an expression. It's a perfectly valid expression, but if you parse an equal sign after your expression, then you know it's an assignment. The first example sets the field, the second gets it. I get it. This means we can parse the left-hand side as if it were an expression, and then after the fact produce a syntax tree that turns it into an assignment target. It's all good. If the left-hand side expression isn't a valid assignment target, we fail with the syntax error. This ensures that we report an error on code like this, a plus b equals c. Right now, the only valid target is a simple variable expression, but we'll add fields later. The end result of this trick is an assignment expression tree node that knows what it is assigning to and has an expression subtree for the value being assigned. all with only a single token of look ahead and no backtracking. Neat. Way back in the parsing chapter, I said we represent parenthesized expressions in the syntax tree because we'll need them later. This is why we need to be able to distinguish these cases. I don't know if that should be an error, right? Should it? I mean, we're just assigning to A. Anyway. Okay, so now we're actually going to implement this visit assign expression. So we have a new syntax tree node, so our interpreter gets a new visit method. So we're going to add that. I'm not going to add it in any particular place. I'll just say visit assign expr self expr assign expr returns a result of an object or a locks error. Okay, and how is this going to work? We're going to call value is equal to self evaluate expr value. We'll say environment assign. We have to say self environment borrow mutt assign expr name as string and value. Right? We have to put an ampersand there, maybe? I don't know. We'll find out. And then we're going to return the value. Oh. So we want to pass in a clone. Okay, value. Otherwise, Rust will say, we moved it here, we can't move it, we can't return it. So let's see what Rust says. It still doesn't like it. Oh, we haven't written assign. Duh. For obvious reasons, it's similar to variable declaration. It evaluates the right-hand side to get the value and then stores it in the named variable. Instead of using define on environment, it calls this new method, right? So we're not defining, we're assigning. All right, so before we do that, I'm going to say, comment this out, because I'm tired of Rust telling me that I haven't written it. Okay, object nil. We'll do that for now. This checks, and we have 2 warnings. Oh, right, okay. Oh, right, I forgot to make cargo check, save it. Okay, good, we're down to 0 warnings. Okay, let's write. I keep forgetting I can just hit env. There we go. So we're going to write assign, but before we do that, let's write a test. Assign value to existing variable. And it should not, yeah, it throws a runtime error if the variable is undefined. So first we'll write it, error when writing to undefined variable. All right, so we're going to need an environment. And we're going to be able to assign to a token. So we'll just grab this token guy here. Let's call him 4. Because why not? And now I want to try to do an assignment. So assert e.assign for toke object nil. And I probably have to do that as well. Is error. Good. And if I run the test, it should fail. Because assign doesn't exist, so let's go write it. All right, pub fun assign mutt self. Name is a token, and then we didn't pass in reference here, so maybe we don't need to object. The first thing we're going to do, we're doing the error case. So if not self values contains, oh, that means we're not going to, it's going to complain about mutability. Key name as string I'm just going to return an error. Oh, right. We need to return a result of either void or locks error. The reason I said void is because that's what they have here. And then otherwise, okay. And if we have an error, then we're going to return an error of locks error, runtime error, of name, and format bang, undefined variable. So it's the same as get. Oh, I want to do this and this and this and this. Okay, so does that check? Does not. Oh, I forgot something. Somewhere along the way I didn't balance things. That's balanced. Oh, how did that disappear? Okay, try again. Here we go. Run the tests. Oh, right. There's no ampersand for this. Okay, 27 passed, 0 failed. We did get some things. Oh, because we're not using things. Yeah, no worries. No worries. Okay, so that test passed. I'm going to have to leave this mut here because I'm about to change it to mutable. So we're going to, because now we're going to write a test for the happy path here. Can reassign existing variable. Okay, so we're going to go through a define. Where's our define? Let's just grab a define here. Throw that in there, and this is going to be 4. And let's make it a number. 73.0. How about 73.1? That sounds good to me. And then I should be able to reassign it to num 89.5. Sure. Right, and then I should be able to actually get the value. So instead of just saying it's that, we can just say num equals this, unwrap, and then just make it equal to that object num. Oh no, I wanted to check that it's okay to do the assignment. Assignment doesn't return the value. I'd have to actually do a get. And where's our values.get? Oh no, just e.get. There we go. So let's grab that, paste that there, and then instead of string, say num 89.5 is that. And this should be, oops, 4. It doesn't check because why? Oh, I missed a closed bracket there. How about here? No, that one's okay. All right, run the test, and it should fail. It doesn't compile. 102. Oh, I put the OK in the wrong spot. Is okay, right? Oh, we still have an issue. 103. Expected enum object found. Oh, reference. Oh, okay. So we can do that. There we go. Okay. So because we haven't written it yet, we haven't been able to overwrite the value of 73.1 with 89.5 because assign doesn't work yet. Okay. So now let's write assign. Boom. So let's flip things around a little bit here. If it doesn't exist, then we'll do that. If it does exist, I'm pausing because hash maps has an entry function that we should be using instead. Yeah. There's example code somewhere. Not here. Yeah, there's example code. Let's find it. It shouldn't be that hard. Hash map entry. Occupied. Rust. Occupational therapy. Yeah. Yeah, here we go. So this is what we want. If let entry occupied object is equal to self values entry name as string, right? And now we have it. We don't have to look it up again. We don't have to say contains key, then write it. We can just put it directly using not remove entry. We don't want that. Get mute, intermute, insert. O.insert, yep. So this has to be mutt. And then we just say object.insert value. Else, and then this is okay actually, right? And then otherwise we do the error. Like that. And then we'll need to pull in this thing. Oops. Oh, I forgot the semi. And what's wrong here? Expected string found. Ampersand. Uh-oh. I don't want to say as string to string. That's kind of silly. Oh, I don't want to move the data either. Can I do that? Ah, I'm doing it all wrong. Bright22 says, do you recommend that game series you did in Rust after reading the book? I'm actually still working on it. I'm only up to chapter 65 out of 1,000,000 chapters. Oops. I was looking for the table of contents there. I'm only up to even more items here. But I do recommend it. If you're asking that, to answer that question directly, I do recommend it. And I will be getting back to this next week. Okay, maybe I just punt and do it this way, because I thought this was an easier way to do it, and clearly I'm doing something wrong here, and I'm not. You can probably remove the explicit borrow. Yeah, but if I do that, oh, duh, that's what the problem is. Yeah, duh. Okay, that took a little effort. Yeah, sure, no problem, Bright. Hopefully you enjoyed watching me struggle with that series, just like I'm struggling with this. But yeah, we're definitely gonna get back to that. It's not running right now, but we'll get that up and running and then check it out. It's a fun game that we're making, and then eventually I want to make my own roguelike, right? After I go through that whole thing, and maybe I'll stream that too. I don't know. Streaming designing code is harder than streaming writing tutorial code, so I don't know how exciting that would be to watch. Okay, so we have 2 warnings, but that's okay. Let's run the tests, and we got 28 tests passing. So this assignment now works. We tested both trying to assign to an undefined variable and getting a failure, That's reassigning an existing variable, and that came back as success. So we're good. The key difference between assignment and definition is that assignment is not allowed to create a new variable. In terms of our implementation, that means it's a runtime error if the key doesn't already exist in the environment's variable map. The last thing the visit method does is return the assigned value. That's because assignment is an expression that can be nested inside other expressions like so. Our interpreter can now create, read, and modify variables. Is that true? Cargo run. A equals 1. Print A. Oh, so this should have been an error. We should have gotten an error from that one. We got a bug there. Var A equals 1. Print A. 1. Print A equals 2. Nil. So that didn't work. So we have another bug. And then print A. 1. A equals 2. Print A. 1. So our assignment is not working. After all that work, we can't assign. Wow, that's terrible. All right, so we have a bug to dig up. What are we doing wrong here? What are we doing wrong? We're running this prompt. So here's the prompt that's running. We have the interpreter. We interpret the statements. It should all just do the thing. Let's go into the interpreter, visit, assign. Oh, yeah, because I'm not doing this yet. That's why it's doing nil. Duh. Okay. Wow, I'm an idiot. Found expected token, found string. Okay. Oh, value. Oh, question mark. There we go. We still have 2 warnings though. Oh, this needs a question mark as well. Okay. Good. Okay, so now does this work? Cargo run. A equals 1. There we go. I don't know why we're seeing it twice. We'll have to look at that later. Var A equals 1. Print A. A equals 2. Print A. Print A equals 3. Print A. So it assigned it, returned the value 3. Okay, so this is all working. Nice. I do want to dig this up, and this line 0 error with nothing there is kind of annoying, but that might be this line here, but I'm not seeing the word expect expression, so I'm not sure where that blank line 0 error is coming from. But meanwhile, let's get this, let's Clippy it. I keep forgetting to run Clippy on things. All right, let's clean these up, and then we can check these in, and then we can call it a stream. Or we could debug, yeah, let's debug the double error message here, and then call it a stream. And then tomorrow we'll get into scope. Right? Global variables are simple, but writing a large program when any 2 chunks of code can accidentally step on each other's state is no fun. We want local variables, which means it's time for scope. All right, so we'll do that. Let's clean these up. So define can take a stir. Here, this can be name, and then initializer doesn't need to have a reference to it. Okay. 1928, 40. Is that going to work though? Yeah, okay. And then, oh, what line was that? 28. Boom. Good. So now, good. Git diff. So what did we do? We added the assignment statement and extended the environment to be able to redefine values, to assign values. Let's clean up that. Okay, so we did the expert visitor for the assignment expert. Okay, so git commit -m added assignment expressions and extended environment to redefine or mutate variables. Okay. So let's see, can we figure out what this double bug is? So if I say cargo run and I say a equals 3, we get 2 error reports on line 1, that undefined variable a, and we get a line 0 error. So I don't know where all these are coming from, but we can take a look. Do we print out any errors here? Just for that. Okay. So where else do we do println? So this is the error that we're seeing here, right? 1 at blah, and so the line should actually be something different, I guess. And then here's where line is coming from. Line 0, location is blank, and then message is blank. So I guess we can start by, this just prints value. Is that the print? That's probably the print statement. That's probably what that is. Okay. Yeah, so whenever we call a parse error, we report it. Whenever we create a runtime error, we report it. And whenever we call a regular error, we report it. But if there's no token, which is this thing here, then we hit this line here. That's where we get the line number business. Which is why I think that this, but this, we should be setting the message in the report. So we should be seeing this expression thing, right? Because it's printing it here. So I'm confused as to why that's blank. If I say assert EQ, no. If message self message is empty, panic, oops. Right, and then we can cargo run a equals 3. So we get the panic. Let's rust backtrace. That way we can see where it's coming from. It's coming from... Oh, run is creating a LOX error directly. So it's coming out of source main. Line 89. 39. 89. There we go. Oh, okay. So this is it. Oh, if parser success. Yeah, that's the thing. Bilbo Baggins. Welcome. Thank you for the follow. Okay. So I don't think we want to do it this way. Then we want to say if parser success, then we want to do the interpret. And I think interpret returns a Boolean, right? Yeah, it returns a Boolean. So we can just say, I don't want nested things here. If parser fails, then we don't want to do the interpret. And we can just return... We'll just say okay, because the parser would have reported the error. Else if that works. Otherwise, interpreter error. I guess runtime error. It should be a little fancier. So this should clean up that first problem. Yeah, but now we're not seeing the parsing error, right? Because there's a parser error here where we're assigning. Sorry, there's a runtime error here where we're assigning a variable that has not yet been created, and we should be seeing the runtime error come out of that, and we're not. And I don't know why not, because you'd think that it would hit that. We see that during, yeah, we see that during runtime. We're hitting this assignment thing. We should see, oh, we should be getting an error back from assign saying we didn't, right. So that would come back to, oh wow, not a lot of tests. It would come back to evaluate maybe, which would return a locks error. Execute would return a locks error. Interpret. Should report an error if the execution fails. I don't know. Println error executing statement. Let's see if we at least, you know, the fact that we're not seeing anything here should mean that we're not hitting that. So let's see. Yeah. So we're not hitting an error. Let's print out when we hit the assignment expression. Println assigning value. So we should see that, right? Ooh. Why is that not executing? Because that's definitely an assignment value. Var a equals 3. Print a. Oh, nothing's working now. I broke something. Oh, I know what I broke. Damn it, because I'm an idiot. Oh my god. That's terrible. Okay, cargo run. A equals 3. There we go. Okay, so now we got this runtime error coming back. We got an error executing statement. This is what the second error report is. And then this is just backwards. So that should be there. That should not be there. That should not be there. And that should not be there because we're already reporting the error. When we create the error, it gets reported. So that's where that double one was coming from. Cargo run. A equals 3. Undefined variable. Let's fix that warning. 164. Nope. Save that. Cargo run. A equals 4. Okay. So we get this. I guess we don't need to do a full report of the error, right? Here we can return an error. I mean, does it matter? We don't really need to. We can just return whether it worked or not. False, true, false. So that becomes that. And now, oh yeah, now we have to deal with this issue here. And if I call unwrap and it's an error, then And we have this issue here. So, how should we handle these? I guess what we can just do is put all this back and just make them all okay. This is kind of sloppy. If parser is not successful, return okay. Otherwise, do that. That's okay. So that means that maybe we can just put this back the way it was before. If parser success, then we can just interpret the statements, and we're done. Oops. There we go. Okay. So now let's try it. Cargo run equals 3. Okay, so now we have a single error and everybody's happy. If I say var a equals 3, that works. Print a equals 4, print a, oops, print a 4. Okay, I think we're good. Get status, get diff. So I'm just going to call this cleanup error reporting. Oh, I don't want this. Although I'm still not happy with the way the error messages look. So we'll have to, maybe we'll take a stream and clean up the way errors are handled. Oh, that's it. So these are all the changes. Very simple. Git add source. Git commit -m clean up error reporting. Need to do more though. Okay, so let's push these up. And this is today's stream. Very nice. We did the Clippy cleanup at the beginning. We finished environments. We finished assignment. And tomorrow we're going to look at scope. And that's where everything goes sideways. Meanwhile, let's go raid toggle and call it a stream. So go over here, toggle bits. There we go. And thanks everyone for hanging out with me. I enjoyed this, and I will continue this, and we will enjoy some scope tomorrow. Let me refresh and click on raid. All right, take care everyone, and have a great rest of your day.
So that one was correct as well. Could it be? Uncle Scientist, welcome. Welcome, Raiders. How y'all doing? How are you all doing? Thank you for the raid, Scientist. Okay, so this is somewhat doing what it's supposed to be doing. I guess it's the paint function that is wrong then. Oh, maybe it's not outputting new line characters when it should. Right? So let's go to the paint function of the text widget. So we're gonna get the text, we're gonna lay out the text.